flip back to whatever a blank page is.
It's right in front of us.
Do you have a blank page right there? Okay. Actually, flip forward. Go forward one page till you get to the graph paper. I'm going to pick some points here. Mr. Acosta, can you pick a point, please? Oh, come on, John. Pick a point in the second quadrant. Something up here. -2, 1. All right, so there's our first point. -2, 1. All right, Justin, pick a point in the fourth quadrant.
Which one is that?
Fourth quadrant, remember it goes in the shape of a C, so this is the fourth quadrant.
All right. 2, -1.
Right, exactly. 5, -4. 6, -4. All right, we need to be a little bit spread out here. My question is, how far apart are these 2 points? So, draw a line in between the two of them. So we're over here at 6, -4. Draw a line that connects the two of them. How long is that line? Well, what we learned on Friday, Pythagorean theorem should help us here.
Oh.
Draw a triangle. What's the vertical piece of your triangle? 1, 2, 3, 4, 5, right? What's the horizontal piece of your triangle? 1, 2, 3, 4, 5, 6, 7, 8. If you know those two sides, is it possible to find the length of that hypotenuse? How do you do it, Grace? Remind us. Okay, no problem.
Well, you would do 5 squared plus 8 squared equals c squared.
Okay, 5 squared plus 8 squared equals c squared. That's 25. If you don't have your calculators out, get them out, please. 25 plus 64. I get 89 equals c squared. And then, Grace, from there?
Oh, you take the square root.
Okay, so someone take the square root of 89 for me.
9.439.
So 9.4. So exact answer, square root of 89. Approximation, 9.4. How do you find the distance between 2 points? The Pythagorean theorem does it for us. Now, what's the drawback of doing it in this method? It takes time. But that's the theory behind it. Effectively, Justin, it's 2 points on a graph. We draw a vertical, we draw a horizontal, we find how long the vertical and the horizontal are. We use the Pythagorean theorem to work it through, and we get our answer. Now, that is pictorial. That is shapes. That is designs. That's a diagram. However, algebraically, we can do the same thing. I want you to think with me. How far from -2 to +6? 8. How far from 1 to -4? Isn't that the vertical and the horizontal? 8 and 5. So, slide across. Let's look at today's stuff. At the top here, I have a big, long square root. We need to understand what these are. Whenever you see a little x with a little number below it, that means like a name. This is the second x. This is the first x. This is the second y. This is the first y. Yeah, you do this in physics, subscripts, okay? You guys ever, have I shown you this before? What does delta mean? Change. Come back to here. What was the change between -2 and +6? 8. What was the change between 1 and -4? 5. Do I care that it's going right or going left? All I want is how far apart they are. I don't care which direction it is. I don't care if it's up or down. I just want to know how far, how big's the triangle. So as we come back, let's look at this equation here. And I'm going to do these problems differently. All right? First, we're going to use the straight equation. All right, I'm going to call this point 1. I'm going to call that point 2. So using this equation exactly straight, it looks like this. Distance equals the big long square root of, which one of these is x2?
2. 9. Sorry, that was my fault.
So 9 minus 5 squared plus 2 minus negative 3 squared. You see where I got those from?
So can it just be
x1, x2, y1, x1, y1, x2, y2. So, what's 9 minus 5?
that's 4.
4. What's 2 minus a negative 3? 5. What's 4 squared? 5 squared. Add them together. How much? 41. That's my exact answer. What's my approximation? 6 point, help me? 4? Formulaic. Difference, squared, add them together, take the square root. Grace?
Is this the same as like a squared plus b squared? So could we just do that?
We could. We could, and that's what I'm going to do on the next one. Okay? Let's look at this next one. The difference between P and Q, that distance. A squared, B squared. You see that? The square root of A squared plus B squared. Now, let's look. How far is it from 6 to 10, guys?
4.
Isn't that A? Wouldn't you say A is 4? So let's stick a 4 in there. How far between 7 and 11?
4.
4 again. 4 squared is?
16.
16. 4 squared is?
16.
16 again. 32. Now, we need to review a little bit back from section 1. Let's break down 32.
5.6.
Well, that's the approximation, but I need to break it down to be exact. 32, remember, is 2 times 16. 16 is 2 times 8. 8 is how many 2's? Break down my 8. 4 and 2. So I break down my 4, 2 and 2 and 2. There's my pairs. A pair of 2's square rooted comes out as 1, 2. That comes out as 1, 2. So 2 times 2 is 4. So my exact answer is 4 root 2. My approximation is 5.6. You need to be able to do both. So this is a little reviewing of simplifying a radical versus an exact answer. Exact approximation, depending what you have.
Do it either way on this one. Can you get the approximation?
Well, I want you to be comfortable doing both, because you need to be able to give me the exact answer, or if I say round to the nearest tenth, obviously then I'm asking for a decimal. But if I say what is the answer, and I don't say rounding, then you need to go 4 squared to 2. So you need to make sure you respond in kind. Yes, Josh?
We know exactly established, so could it be broken all down to 2?
You could have stopped right here if you would recognize that 16 was a perfect square and jumped right to 4 root 2. But no one stepped up and said that, and so I continued to break it down into my smallest pairs. If you guys ever want to step up, help me recognize a perfect square.
How do you get the 4?
Well, you see how 16 is a perfect square?
No, I get that, but from the 2's I don't.
Oh.
You just
Square root of 2 times square root of 2 is square root of 4, right?
Yeah.
And what's the square root of 4? The square root of 4. 2. So this right here is a 2.
Okay.
Same way, that's a 2, and 2 times 2 is 4. We'll do another one to practice that. All right, down here, distance. M and N. How far, Abby or Brett, between -4 and +4? 8. Okay, so 8 squared. Abby, this one's yours. How far between 2 and -3? 5. Okay. So 5 squared. Hannah and John, 8 squared is? Hannah, 5 squared is? 25. Add them together. 89. 89 does not break down. So, approximation? 9.4. They're both valid answers. Zach? Well, I know 89 does not divide by 2, or by 3, or by 5. Doesn't divide by 11. Doesn't divide by 7, because that's 84 and 91. Doesn't divide by 17 or 13. I just, from experience, I just know 89 doesn't break down. Yeah. If possible, or you can break it down by the pairing method. Okay? All right, flip her over. Now, on none of those problems on the first page, did we draw a triangle? No, we don't need to. Could you? Could you do it graphically? Sure. And you could draw your A and draw your B and see that relationship. But, you know, Brett and Abby were very quick to just do the difference and figure it out. All right, let's say if you have a shape on the coordinate plane, you're asked to find the perimeter, find the coordinates, find the distance of each side, and then add them up. So here we have a triangle. Here's point A, here's point B, here's point C. Plot those 3 points on the graph right now and label them A, B, and C. Plot all 3. Okay? Plot A, plot B, and plot C. Once you have them plotted, draw your triangle. All right, we have 3 distances. AB, BC, and AC. Who can help me with AB? Shalon and Luke, can you help me with AB? How long is AB? Did you say or no? 5. Thank you, Luke. All right, AB is 5. How does he get that? Just from counting blocks. Boom, 5. All right, BC. 9. Okay. How do I find AC?
You gotta do square root of A plus square root.
So 25 plus 81. Where am I getting 25 and 81 from? A squared plus B squared, right? 25 and 81 is 106.
2 and 53.
2 and 53. 53 doesn't break down any further. So I guess we're back to 106. But what is the question? It says round your answer to the nearest what? So are they okay with going decimals here?
They are.
Yeah. Katie, question?
Wait, why do you have 25 and 81?
A squared plus B squared. Because this is 5, and that's 9. Hence why the picture is a nice feature. So what was this as a decimal to the nearest tenth, guys?
10.3.
2 or 3?
3.
It's
3, okay.
10.29.
So let's add these together. 5 plus 9 plus 10.3. I get 24.3.
Are we supposed to do that?
Well, what's the question? Find the what?
Perimeter.
Find the perimeter. And if we're going to find the perimeter, we've got to add them up. So here we are, we've added them up, so the perimeter equals 24.3. Is there units of measure here? Is there centimeters or inches or anything like that? So we should just probably put units. There's 24.3 units. All right. Short assignment tonight.